Hello everyone, my name is Supriya, working as Assistant Professor in the Department of PG Studies and Research in Statistics, SDM College Autonomous Ujre. I am going to speak on the topic that is interval estimation of the mean response and future observation of the response in simple linear regression. So first let us start with how to construct confidence interval for the mean response in the case of simple linear regression. A major use of a linear regression model is to estimate the mean response, that is expectation of y, for a particular value of the regressor variable x. So let us consider x0 to be a particular value of the regressor variable for which we wish to estimate the mean response. Let us denote it as expectation of y given x0. So we assume that x0 is any value of the regressor variable within the range of the original data on x used to fit the model. First, let us try to find what is the estimator of expectation of y given x0. So an unbiased point estimator is given as expectation cap of y given x0, which we can write it as mu cap y given x0, which is equal to beta naught cap plus beta 1 cap into x0, which we are finding it from the fitted simple linear regression model. Now, in order to obtain the confidence interval on the mean response, so we need to consider the distribution assumption. Since we assume that the response observations yi follow normal distribution and the estimator mu cap y given x0 is a linear combination of the observations yi, so therefore we can assume that the estimator mu cap y given x0 is normally distributed. So let us try to find its variance. So we know the expression for mu cap y given x0, which is beta naught cap plus beta 1 cap into x0. Now let us substitute the expression of beta naught cap, that is y bar minus beta 1 cap into x bar. So here you can observe that in the second and third term beta 1 cap is common. So if we take it outside, we get x0 minus x bar. So now the expression is in the form variance of a plus b. So variance of a plus b is variance of a plus variance of b plus 2 into covariance between a and b. So thereby we are getting variance of y bar plus, here in the second term we can obtain that x0, we can see that x0 minus x bar is a constant. So it can be written as x0 minus x bar whole square into variance of beta 1 cap plus 2 into x0 minus x bar into covariance between y bar and beta 1 cap. So note that the covariance between y bar and beta 1 cap is 0. So thereby the third term will become 0, and variance of y bar is sigma square by n. Since a variance of yi is sigma square, so the variance of its sample mean will be sigma square by n plus the second term, that is x0 minus x bar whole square into variance of beta 1 cap, which we already know, that is sigma square divided by sxx. So therefore the final expression, so here we can observe that in both the terms sigma square is common, so we can take it outside. So it is sigma square into 1 by n plus x0 minus x bar whole square divided by sxx. Now, in the variance expression, we can observe that there is sigma square which is unknown to us. So, we have to replace sigma square by its unbiased estimator, that is residual mean square. So, this becomes the expression for the estimate of the variance, that is variance cap of mu cap y given x0. And we can observe that the sampling distribution of the statistic, if we consider, that is mu cap y given x0 minus expectation of y given x0 divided by standard error. So this follows student t distribution with n minus 2 degrees of freedom. So thereby 100 into 1 minus alpha % confidence interval on the mean response at the value x is equal to x0 is given as mu cap y given x0 minus t alpha by 2 comma n minus 2 into square root of variance, that is standard error. So this is the lower limit, and the upper limit is mu cap y given x0 plus t alpha by 2 comma n minus 2 into standard error. So note that the width of the confidence interval, so width is upper limit minus lower limit for the mean response is a function of x0. So here the interval width is minimum for x0 equal to x bar, and it widens as the absolute value of x0 minus x bar increases. Now let us move on to the next topic, that is constructing a confidence interval, or we also call it as a prediction interval for the new observation of y. So here Here we predict a new observation y corresponding to the specified level of the regressor variable x. Let us take it as x naught. So the estimator of y naught, that is y naught cap, is given as beta naught cap plus beta 1 cap into x naught, which is from the fitted simple linear regression model. So now let us develop a prediction interval for the future observation y naught. Now for this, let us define a random variable psi, which is equal to y naught minus y naught cap. So since it is nothing but the residual, that is difference between the actual value and the predicted value. So this follows normal distribution with mean 0 and variance. So let us try to find the variance, that is variance of y naught minus y naught cap. So this is in the form variance of a minus b. So that is variance of a plus variance of b minus 2 into covariance between a and b. So since we know that the future observation y naught is independent of y naught cap, so therefore the covariance terms become 0, and thereby coming to the variance of psi, so we get variance of y naught is sigma square and variance of y naught cap, that is variance of beta naught cap plus beta 1 cap into x naught. So let us proceed to find this. So once again, using the similar approach that we have seen in the earlier interval estimation. So here let us substitute for beta naught cap and let us take beta 1 cap as common. So once again we are getting in the form variance of a plus b, that is variance of a plus variance of b plus 2 into covariance between a and b, where the covariance terms become 0 and the remaining. So thereby here we can observe that in all the three terms sigma square is common. So if we take sigma square as common, so the final expression we are getting for variance of psi is sigma square into 1 plus 1 by n plus x naught minus x bar whole square divided by sxx. So once again sigma square is not known to us, so we have to replace sigma square by its unbiased estimator. So therefore the estimate of the variance of psi is given as residual mean square into 1 plus 1 by n plus x naught minus x bar whole square divided by sxx. So now we can construct 100 into 1 minus alpha % prediction interval on a future observation y naught at x naught, which is given as the lower limit y naught cap minus t alpha by 2 comma n minus 2 into square root of variance, that is standard error, and the upper limit y naught cap plus t alpha by 2 comma n minus 2 into standard error. So here we need to note that the prediction interval will be of minimum width when x naught equal to x bar and it widens as the absolute value of x naught minus x bar increases. So finally, if we compare the prediction interval with the confidence interval that we have discussed, so the prediction interval at x naught is always wider than the confidence interval at x naught, because the prediction interval depends on both the error from the fitted model and the error associated with future observations. Thank you.